Hello, Nat Sakimura here. This movie is a recap of DID SIOP panel, which was done at Identiverse on the 23rd of June 2021. The panel starts with Kim Cameron's remark on the subject, and then I explain the OpenID claims model. Then Kristina Yasuda, who is the chair of the SIOP Special Core, explains the current status of the DID SIOP specs. And then we discuss some of the more prominent questions that we are facing, namely setup between the wallet and the claims provider, binding of the claims and credentials to the user, trust model, security model, controllability of the wallet, and wallet invocation. These are the problems that are needed to be solved before making distributed identity really operational. So if you are interested in the subject, I'm pretty sure that you are going to like the panel. So without further ado, let's start it. All right. Hi, everybody. Welcome to the SIOP panel. I'm Nat Sakimura, your moderator today. SIOP is a special kind of OpenID provider that runs on your local machines, such as smartphones. It's recently attracted some attention in relation to DID and VC, verifiable credential, that led to the joint effort by DIF, W3C, and OIDF to expand its capabilities. For today's panel, I have three distinguished panelists. Kim Cameron, the author of Laws of Identity and Identity blog, Kristina Yasuda, Identity Standard Architect at Microsoft, and Tobias Looker, Technical Standards Architect of Matter. So to start with, Kim will give us a few remarks in this space. So Kim, please.
Thank you. Here at Identiverse, everybody's an IAM expert and therefore familiar with today's leading IAM technology, OpenID Connect, IAM being the industry category for identity and access management. But the wide adoption of OpenID Connect by enterprises and by large web services like Facebook, Google, and others has led people to sort of assume that OIDC is really about other entities that provide you with an identity and make claims about you and control your identity. This whole model has been very useful to organizations, but and to the internet as a whole, in the sense that it helped clean up security on the internet to a great extent. But of course, the model in which your identity is controlled by a third party has its limitations and has its problems, and those problems have been coming to the fore for some time. And so the question then is, it's led to people being more interested in the decentralized model and how we can solve things. And a lot of technical people have just assumed, well, in order to do that, we have to basically rewire the whole internet. We have to rebuild the internet from scratch using new protocols. And in fact, in 2014, OIDC standard included a section called Self-Issued OpenID. And the concept there was that people would have their own identity provider and would be able to participate and send assertions to relying parties that way. So it was already an SSI solution, but it was overlooked by virtue of the overwhelming success of the sort of enterprise and web service uses of OIDC. But in this panel, what we're going to do is discuss the extensions to the standard that provide a way for self-issued identity and VCs to be propagated quickly by reusing the rails of OIDC. So, I mean, to put this in a nutshell, if you think of conventional OIDC, and these are, please excuse the vastly simplified diagrams, they do get the point across, I hope. The user goes to a service provider. The service provider redirects the user to a OpenID provider. The OpenID provider authenticates the user using some mechanism like a username, password, or something else. And then makes a series of claims about the user, for example, the user's ID, and potentially other claims, and those are returned to the service provider, and that's the model we're all very, very familiar with. But the SIOP model, defined in Section 7 of the same specification, provides for basically an OpenID provider that would be run by the user. In most cases, initially, the thought was it would always be run on the user's device, and therefore it's sort of an early version of a wallet mechanism. And indeed, that may be the case, or thinking about it more generally, it could be run by service providers on behalf of the user if the user fully trusts them to be their proxy, if you want, for this type of thing. So the concept is that the operator of the identity provider, of the claims issuer, is the user, the entity that controls what is stated and what the keys. So let's go to the next stage. And so if we can keep that model in mind, we have the advent of DIDs and VCs being a hugely important factor, and perhaps the most important thing to have hit the internet in my lifetime, from an identity point of view, because it kind of recapitulates everything we had learned about claims prior to that, and formalizes some more things that make statements by third parties really useful. And then the DIDs are ways of being able to have your own identity that you control, expressed in a format that interoperates. So unlike a number of the other alternatives for SSI that are being deployed, the SIOP model that I just described uses the OIDC protocol, the one that has been in place for 7 years, and the key distribution mechanisms, which have proven to be safe and reliable on the open web in spite of continuous attacks. To me, this is an important thing, that it has survived from a security, and it's a proven technology that allows us to get VCs and DIDs into use quickly without being dependent on protocol that is still being tested and is sort of in its early stages. Certainly, I'm in favor of other protocols that introduce new capabilities, peer-to-peer capabilities, and so on. But we also have to be realistic about, okay, what are we really moving the entire world over to a VC platform? And if so, can we trust that it will be safe? And the OIDC rails give us a mechanism for ensuring this. The other thing is that it has other benefits. With minimum engineering support, SIOP identity tokens can be used instead of usernames and passwords to assign users roles and permissions in the back-end OID systems running through almost every enterprise and organization. So if, for example, you work at, ABC Corporation, you could be using verifiable credentials to log into that, and it can then take those credentials, and because of the format being the same between the OIDC SIOP mechanism and the back-end mechanism, the verifiable credentials and the related crypto proofs and everything can be passed along. So this is what I mean by reusing the rails. Because the SIOP and backend identity tokens share the same structure, you basically have this ability to get everything through into the backends, including all the way to the backend applications. So the OpenID Foundation, as Nat says, has been collaborating with others in order to work on these problems. It's also been working to reduce vaporware emissions, if you want, by developing proven extensions to the existing OID standard that are validated by multiple implementations before we're taking them very public. And doing all of this in preparation for standardization. So the date of our first SIOP v2 interop event based on these extensions is still being finalized, but will be announced here at openid.net and https:/identity foundation. So now Kristina, Nat, and Tobias will share the details. Thanks very much.
Thanks, Kim. OIDC actually has 3 claims model depicted here. Simple claim is the most prevalent model where relying party registers to OP during setup, and OP provides claims that it manages in JWT to relying parties. And there is an additional actor called authoritative claims provider, ACP, in the case of aggregated claims and distributed claims model. Also, we are starting to call what was OP in the simple model as intermediary provider, IP, as it gets really confusing to use OP because ACP is an OP to IP here, and IP is an OP to RP here. And SIOP is kind of IP. So Kristina will now give us some overview of recent development. Kristina, please.
Thank you. So this OpenID Foundation, within the Connect working group, we have been having special calls dedicated to this topic, and I would quickly report on the progress we have made in the past year. So there's 3 components, and this is still being discussed in the working group. The first is the self-issued OpenID provider model itself that has been elaborated on, and which is based on the Chapter 7 of OpenID Connect. But there are some sort of additional feature that needs to be discussed to make it workable with its recent developments. So think of it as a foundation layer that deals with registration, discovery, invocation of self-issued OP, ID token, and all the well-known mechanisms. And second, so I'm reusing on the slide that Nat has been using as a claim types. The second component is how does a self-issued OP presents verifiable presentations to the relying party. So using ID tokens in other formats native to the OpenID Connect, in addition to that, how can that be extended to include verifiable presentations and different formats that they can be expressed in? And the third is the claims aggregation model. So how ACPs, authoritative claim providers, the issuers of the claims, can issue claims in the self-issued OP in a way that can be, in a trusted way, it can be presented, then SIOP can use to present to the relying party. And this is just to walk through some keywords that we have been discussing and some limitations. First, the ID token is signed by the single subject. So what has been discussed is using cryptographically proven subject authority in subject signed tokens, which potentially, so this is where using decentralized identifiers as a mechanism to derive the keys which are used to sign the tokens comes in, which is not the only mechanism, but it is one of the mechanisms. Another limitation is reduced backchannel accessibility because self-issued OpenID provider, if it's sitting on your device or browser wallet, which means it's limited to the implicit flow, and there's no way to differentiate SIOP instances, which means you don't know if you're talking to the same instance you've been talking before, or when you're going to talk to the same instance next time. So that leads to idea of just-in-time client registration. Is there potentially some overlap with newly developed draft in OpenID Foundation, which is called OpenID Federation specification? So this hard-coded policy switch refers to a set. Think of it as a discovery. What there's the metadata and supported by the self-issued OP, and then finally the self-issued OP invocation. What happens if you have several self-issued OPs sitting on your device, on one device or one browser? And potentially, the trust framework conversation comes in here, where the self-issued OpenID providers can be grouped, seen as a group or a set with common capabilities. So you don't trust this particular instance, but trust the group behind it. And second, this verifiable credential model. So ideally, we would want to work it not just with the SIOP, but all existing Connect flows. And two mechanisms we've been exploring is embedding verifiable credentials / verifiable presentation directly inside the ID token, or having a separate artifact or separate token code which just represents verifiable presentation being sent back directly. And following 3 slides are just quick examples of how that might look if encoded verifiable presentation that can be decoded. And then if that verifiable presentation is expressed in, so you can see the VP JOT embedded in as all the rest of parameters of the ID token. And if it's expressed in the JSON OD, for example, you will see the JSON OD linked data formatted verifiable presentation embedded directly into the ID token. Or, as in the next slide, if you can skip the explanations, you would have, you use a claims parameter to show that it's which claims are included in the VP token, and the above example is ID token, and below is bounding mechanism between ID token and VP token, and VP token is sent back separately. So just several mechanisms have been concretely proposed and merged in the draft. So that's from my side.
Thank you, Kristina. So before going to these discussion items I have prepared, Tobias, do you have some comments or something to add?
Yeah, no, I think in general, the model outlined here and the work that we've been doing is across SIOP touches multiple components, and as the discussion here highlights, there are multiple phases to the setup around a SIOP, so they can claim these credentials or these portable identity assertions in a way, and then perform aggregate presentations as Nat highlighted in the aggregated model downstream, and some of the unique limitations that come when deploying an OpenID provider at the edge.
Thank you. Let me start with the first question. Setup between IP, intermediary provider, and authoritative claims provider. So in the case of traditional OpenID providers in aggregated claims, it actually registers itself as OAuth client or OpenID client. The IP registers itself to the ACP. How does it happen in the case of VCs?
I can take that one.
Please.
Yeah, so I think the important thing here in this phase, we have kind of a conventional OpenID Connect model where we've got the self-issued OpenID provider is essentially a relying party at this phase, and they're conducting a conventional OpenID Connect flow to have the end user authenticated and a set of claims prepared for them and returned. The only difference is that the claims being returned, the one fundamental difference we have today is that the claims that are going to be returned are going to be returned in a form that recognizes that relying party would like the ability to be able to represent those claims downstream in an authenticatable manner to another relying party, because they're fundamentally sort of aggregating them in the end user's wallet, so that that credential or that unique set of claims from that authoritative claims provider can then be represented downstream. And we tend to call that kind of a form of binding to how do you appropriately establish that intermediate provider's role in the interaction, and how does that get appropriately represented and conveyed downstream to the relying party so that they can not only authenticate a presentation of a set of claims that originated from a particular authoritative claims provider, but they can also understand that the intermediary that is doing the end user authentication and ultimately presenting that end user assertion to them is suitably authorized to do so. So it's a conventional OpenID Connect flow. There's been work around that it's gone by multiple names in the working groups today, which is credential provider, with credential being a unique kind of, essentially just in the most abstract sense, talking about a group of end user claims, an alternative vehicle for a group of end user claims that has a suitable way to bind to an intermediary on its presentation to a relying party.
Yeah, and one of the feature of the verifiable credential related stuff is that ability actually to get stored in IP in this figure, right? And then used later. Well, in the case of OpenID Connect, traditional ones, we punted on it. It was kind of hard to do the selective disclosure after the fact. We opted to do everything dynamic so that the ACP here can make the constrained claims expression to start with to suit with the relying party's request. So I'm imagining that verifiable credential is using something like ZKP or other techniques to make it possible for the stored credentials, right?
Yeah, so selective disclosure obviously is a concept that's front of mind in OpenID Connect today, and when you have a direct relationship between the relying party and the provider, a request for a scoped set of claims can be made, and selective disclosure as a capability is achieved. Essentially only the claims required by the relying party are returned. But as soon as you get into a model where you have an intermediary where the relying party is making a request to the intermediary provider for a subset of claims that might have been involved in a larger claim set authored by a authorized claim provider, you have a few different ways to accomplish selective disclosure. You've got what I tend to call a just-in-time sort of model, which requires the IP to have kind of a dynamic relationship with the relevant authoritative claims provider and go back in real time and request that claim set or that subset claim set that's going to fulfill the relying party requirements, versus a model where perhaps that is the ACP is not offline or is offline, or other constraints around the presentation model mean that they don't want to recontact that ACP in real time. In that case, you get into alternative mechanisms to perform selective disclosure, and one of those ways to do so is using new cryptographic techniques such as zero-knowledge proof enabled digital signatures that fundamentally allow you, when an original kind of claim set is prepared, or credential or identity assertions prepared, the intermediary can, without having to get a new one issued, essentially derive a selectively disclosed identity assertion that is still offers the same protections we've come to be familiar with around digital signatures, and still validatable by the relying party back to the ACP.
Thanks, Tobias. Kim, you're muted.
Thank you. There, I'm okay now.
Yeah.
Yes.
The basically the what you're calling the IP, let's call it the SIOP mechanism in this case, is able to store more than just frozen claim. It's able to basically, it can store metadata about the claims issuer, and it can store actual, what can I say, verifiable credentials that I think of them as frozen, because they're signed, sealed, and delivered, and last for X amount of time. At that point, they no longer work. And that introduces a bunch of issues like, well, what happens if you have basically data that has short lifespans? You may want to be able to have an automatic refresh mechanism where not necessarily when you're actually accessing something for privacy reasons, but in the background, the system is culling more recent data, more recent assertions from the verifiable credential issuer. And so the nice thing about the model that we have is that it permits that. And in a sense, for those familiar with the claim names and claim sources concepts, some of those are able to be reused here, where basically the relationship between the verifiable credential that is stored in the wallet and the verifiable credential issuer is more elastic. It can be that the one that you see traditionally in a lot of early SSI implementations, but it can also be something more malleable and more susceptible to handling short-term data that has to be kept refreshed. So it's very interesting.
Do you have anything to add, Kristina?
I had the same comment with Kim, that now it's not dynamic. You need to sort out, that refresh and revocation mechanism, which are the hardest part. So I think
all right. And we are still working on it, right?
Yeah.
Okay. So then let me go to the second question, which is binding claims to the session or user in the usage phase. So in the case of OpenID Connect, it's the traditional one is kind of simple because everything is dynamic again. But if it's a store on the forward kind of things, it gets tricky. For example, you may want to have verifiable credentials or things like that stored like X numbers of years before, and having it stored in your wallet or IP here and use it at later time. Now, for the privacy reasons, you may not want to bind that thing to the omnidirectional name or identifier. And that makes a lot of things complicated. So how is being envisioned to be done in this space?
Well, I'll make a comment on that because I've been working with an implementation that handles that problem. One way of doing it, and what's good is the proposals that are being agreed in the working groups allow multiple ways of resolving these things. So for example, one can have the wallet can maintain separate keys for each relying party that the user interacts with, and the wallet can organize, which is, and when I say wallet, I'm really talking about SIOP and some associated organizational capabilities inside a particular implementation. It can decide that that it will actually request a separate, using the initial verifiable credential which it receives. It can request separate relying party specific credentials that can then be decorated in various ways and are not linkable across. So it isn't actually a very complicated thing to do in order to be able to have these multiple keys present, and the thought is that the number of different relying parties that you're going to use with a given credential will be limited, and it's certainly no storage problem. So that's one way of doing it. There are other ways of doing it which use the new credential, and great progress being made based on Matter's anonymous credential technology. And all of those things are supportable within the same model and work today. There are entities we found that really don't want to get involved with anonymous credentials at this point in time, and still want to receive those privacy benefits. So the ability to have pairwise keys for multiple different relying parties is attractive to them. Once again, the good thing about the model that is being developed and the proposals that are being developed is they don't actually force you into a single one of these solutions. The wallet and you know can use various mechanisms for interacting with the verifiable credential issuer. Now, hopefully, over time, all those different mechanisms can be standardized as well. But in the beginning, those can actually be sort of things that are shown to work in practice and then be standardized.
Can I? Okay.
Yes.
So there's verifiable credentials. You have a subject identifier, which can be a decentralized identifier inside the verifiable credential. And I quickly put in a chat, but ACP issues a verifiable credential to the intermediary OP, but the intermediary OP presents VC with a proof of possession as a verifiable presentation to the relying party. So that is where, if the subject identifier in a VC is a DID, you can use that key to sign the proof of possession. So there's sort of this binding that it's me to whom it has been issued who's actually presenting. Taking aside pairwise DID issues on the side for now, but that one is a mechanism.
Yes, I think in general, when we think about this, I think essentially the general problem we're trying to solve for is how does the relying party, when a claim set is presented that was authored or signed by an ACP via an IP back to the RP, how does the relying party suitably authenticate not only the set of claims that are being presented that were originally kind of issued or signed by the ACP, but that the intermediary obtained that in a transaction that involved the end user's consent and authenticated, and that kind of delegation from the ACP to them is sound and has kind of been performed and is essentially a reliable presentation of that claim set, and all the kind of common assurances we've come to know and rely upon in the conventional model when there isn't an intermediary at play. And so that binding, I think in general, we talk about as a kind of generalized process, and as been discussed, there are multiple ways to accomplish that. There's almost what I would refer to as transactional binding, which is in real time the relying party. Again, it's the just-in-time sort of model where a relying party makes a request, and that request includes, I want these claims and they must be authorized by, they must be kind of authoritatively stated by ACP1. So the intermediary provider at that point in time during the transaction's life cycle and receiving the request from the relying party conducts a new OpenID Connect request back to that ACP to obtain that subset of claims. And they might include the forward information from the original requests they've received from the relying parties, such as the nonce or other kind of session information, so that the subset of claims that the relying parties after that they obtain on the behalf is suitably kind of transactionally bound to the request that the relying party made, so that the relying party, when they receive the presentation, can it's transparent to them that these claims have been kind of obtained within the life cycle of their transaction, and therefore authenticates that intermediary provider. Another way to accomplish that is through kind of a proof of possession element or a cryptographic proof of possession element, as as Kristina said, which is using technologies like decentralized identifiers or public keys directly. So essentially, if when the IP requests the claim set, they give a public key to the ACP and say, please include this in the claim set you issue, and then I will prove possession over the private key when I present this to the relying party, then the relying party knows essentially that claim set was suitably bound and delegated to that intermediary provider, and it's not merely kind of a more conventional sort of scoped claim set. So
there's a question on the chat saying, what prevents the owner of the wallet from mashing up claims from different claims providers?
Can I take this one?
Please.
So one way, I mean, there are several ways, but one way we're working on is defining a more robust request query syntax in the request that would allow to specify the credential types, the status in the request. So one thing we're looking at is presentation exchange specification in Decentralized Identity Foundation. So in the response would have to be compliant to that requirements in the request. But that's, there should be trust in the claims aggregator.
Thanks, Kristina. Okay, so in the interest of time, I might want to go to the next question, which is the trust model and the security model, which may be related to the current question as well. But in the cloud-based famous provider managed model, identity provider, OP, I wrote IDP because someone also goes there. It was easy to kind of trust because you can go after those providers, But when it's self-managed, the situation is a bit changed. So what is, there needs to be some kind of trust towards operational level, as well as, it's kind of hard to do the server authentication, especially on the smartphone wallets. So do you guys have any comments on that? Tobias?
Yeah, sure. So I think in general, as you point out, there are some unique challenges that occur when you take a conventional kind of deployed provider and you kind of shift its deployment model. So rather than having almost a kind of centrally operated and delivered provider where you rely upon kind of well-known cryptographic keys associated to that provider to authenticate artifacts such as ID tokens coming back to kind of suitably identify the provider and then kind of layer on the trust model that is used in OpenID Connect today. It essentially shifts and unique challenges are created when instead you take that provider and the bulk of it is now running sort of at the edge or on the end user's device. How does the relying party still kind of ascertain the provider per se, even though it is now running kind of locally, the identity of that provider? So whether it be an app, who is that app, and do I trust that app? What's the process they go under end user authentication? When they say they authenticated the end user, do I trust that? And a lot of that comes down to kind of key kind of challenges around kind of authenticating like that software instance and how we can essentially suitably have the same assurance as we have in the deployed model.
Can I just quickly?
Yeah.
So one I quickly touched upon, but the idea of trust frameworks, and we already do see some of them emerging, like mobile driving license. It's kind of like verticals, right? Where you have these providers agreeing that these are the rules based on which they will trust certain app providers, certain OP instances. And things happening now is that those verticals seems to find a new technology. So what we need to do is to find a way to make this horizontal kind of SIOP technology be applicable to different verticals where it's, each trust framework separately assures this trust model. And second thing, maybe there's interest to discuss this in relation to the hardware authentication key with the attestation, so FIDO-related conversations. This is still a really new developing area, but I think there is some interesting opportunities there as well.
Thanks,
yeah,
Chris.
well, one of the things that that we've seen in the actual deployments of these things is that is people actually immediately start to project what's basically a trust framework, because they'll say, well, we want to control which wallets. Will we be controlling which wallets can we, if you're a verifiable credential issuer, do you want to control which wallets can accept your verifiable credential? And if you're a relying party, do you want to control which issuers are able to issue a specific credential? Like if you have a standardized credential that can be presented by a number of different issuers. And similarly, you have, for example, systems where you want to be able to control, for example, health systems that deal with sensitive information, like, whether you have various diseases and DNA issues and so on. They want to be able to control which relying parties can actually get into the system as well. So there's in an actual deployment, there ends up being a trust framework defined. And so now the question is, to what extent can we sort of standardize what those characteristics are of the trust framework and make that something that people can use across different, across the whole spectrum of wallets, verifiable credential issuers, and so on, including protocols, I would expect.
Thanks, Kim. And in the interest of time, I'd like to skip this question, which is going to be too hard, I think, for the panel. And this question also comes up quite often. Wallet invocation. Are we going to end up in yet another NASCAR, or do we have any solution? Anyone?
So the current solution is to use custom URL schema, where you would have OpenID : which is a way that to open up a certain wallet on your device, but that introduce a lot of OS dependency. So without collaborations there, it's a bit hard to achieve. We are working on something called SIOP Chooser, which uses universal links and the selector inside the, how you select apps to which you want to share your picture, for example. So that kind of capabilities, but it feels more like a hack right now. So if anyone has better ideas, but right now it's a workaround.
Tobias, did you want to say something?
Yeah, well, I just think in general, I think the idea that has been kind of visited in several this is one of the hard problems that's endured across several iterations of identity technologies, which is revisiting the kind of interaction model between the end user, the provider or providers, and the relying party, and how does that kind of interaction model play out today? The predominant kind of pattern that we see deployed is that the relying party makes a list of the providers available through logos as login options when for who the relying party can use. But we come to know that an end user can often land on a login page and associate themselves with multiple login options. I've done that numerous times, and it doesn't necessarily tell them which one is the one that they usually use with relying party, which one they should proceed with, or kind of potentially takes other login options that they would otherwise want to use off the table. So there are, I get the model that's in SIOP today, which is, as Kristina said, which is using universal links as a simple mechanism, but it has with custom URL schemes. But it's a simple mechanism, but it has its limitations, such as what happens when I execute login with a self-issued OpenID provider, or expect there to be a registration to that URL scheme and there isn't one. How do I kind of deal with that default state, still kind of suitably providing the end user with a path to complete a login transaction? So in general, this is a really interesting space, and it is a really hard problem to revisit around the interaction model between these three parties.
Thanks. Okay, so we are almost approaching the end of the panel, and there was one question which hasn't been answered in this panel, but was asked in the chat. Is there any COTS product for doing something like this? I imagine not, because we are still developing it, but if you guys know any toolkit or something.
Well, Microsoft has been building an SDK that in client APIs that you can use right away to build an issuer and verifier in your wallet too. There's 3 different SDKs that you can use right away. And I know Matter's been building something too, so there are SDKs being available.
All right, so hopefully that kind of answered.
Kind of.
Yeah, it's not really COTS yet. Right?
Yeah, I know, yeah.
Yeah. So, okay, so to finish with the panel, I believe we are finishing in 2 minutes. Let me go around in the order of, say, Tobias, Kristina, and then Kim to finish off this panel. The last words?
Yeah, no final words from me. Thanks for the panel, though, and really enjoyed it.
Yeah, just very quickly, I think it's Identiverse. It's been great to see how many people have been looking into investigating into VCs and DIDs, and it's kind of this exploration of how that fits into existing products. And it's interesting how the use cases seems to be start agreeing on is the recovery use case, for example. So looking forward to really continuing this discussion and building up on this.
And Kim?
Well, I guess I look forward to the interop and to seeing and to actually proving out what we can do in ways that work between different implementations. And I sort of see that as soon as that's done, we could actually have some of these things emerge as COTS.
And Nat, final words from you?
My request for all those of you who are interested in this space is to come to the OpenID AB Connect working group, which you are seeing the information here. All the discussions are actually happening there, and everybody is welcome. Thank you very much for joining this panel.
Thank you.